hope that was once and not during the talk. So, hi, my name is Eyal Oren, from Derry, Galway in Ireland, and I will present to you some work on how we can treat semantic web data as, or in an OO framework, or how can we do OO programming over semantic web data. And I will give you in a second a motivation why this is very interesting. And this is joint work, as is written there, with Renaud, Sebastian, Armin, and Stefan Neppel from Derry, Galway as well. So the overview will be that I will first try to motivate you a little bit why it would be interesting to look at semantic web data as from an OO perspective. And I will give you a little bit of an overview of what you can do with this. I will show you the ActiveRDF. So this is our mapping that we have developed in a library that you can use that actually maps RDF and RDF schema data to OO data. And intuitively, you might think that it's very easy to map to one to the other, but it's actually not. And I will discuss some of these problems if you do an intuitive mapping, problems that you will encounter. And many of these things are actually the same confusions in a way that Boris mentioned just now. What happens if you kind of look at OWL and relational databases? People have a lot of confusions because they think they're doing one thing and they're actually not doing that. And similar things happen if you compare semantic web data with OO constructs. So many people think they're doing one thing and they're actually not. And these are kind of things you have to be careful with when you do the mapping. And then I will show you how ActiveRDF can plug into Ruby on Rails, which is a very interesting combination in my opinion. So just very briefly, since we are in a web conference, let's look for a second at semantic web from an application point of view and compare it to web applications that we can already see now that are very kind of ubiquitous database-driven web applications. And if you compare these two kind of broad characteristics, you could say that typically, not always of course, but typically database-driven web applications are centralized. There is one database and there is one fixed schema, because the application designer, the application developers, they know what they want to do. They have a closed system and they have one type of information that they want to store. So for example, if you want to store people and their profiles, you say, well, I make a schema where I have people and their names and their hobbies, and that's it. Okay, so that's the schema. And if you come along with data about cars and how fast every car drives, you can't fit it in because that's not what the application was designed to do. The application stores people and their hobbies. So you have a fixed schema, you typically have a fixed vocabulary, which you decide again up front. This is the way we are going to call our columns and tables. You have a centralized point of publishing. You have one single data source, and you basically have closed systems, right? Where you design up front what you want to do, and that's the data that gets in, that's the application can deal with it, and that's it. And if you kind of take the other line of thinking, whether you call it Web 2.0, or whether you call it semantic web applications, I don't really care, but it's decentralized, it's semi-structured, so maybe there is a structure you put in, but not all the data does need to conform to it. Maybe there's no schema, so if you want to talk about your hobbies, you can talk about your hobbies, but if you want to add data about your car, you can do that as well. You can use any kind of vocabulary, you can publish it somewhere on the web and somehow it will be found. So you have many distributed data sources, and the systems that you want to build on top of this, so if you want to build an application on top of this, you have to deal with an open environment where you integrate data from open sources and they are not under your control. So the application cannot say, this is the data that will come in, because you don't know what people will do. And that's a very interesting thing, but it's also actually a very complicated thing, because you have to cater for an environment that's not under your control. So the motivation for all this work is, if you look at a database-driven web application, is nowadays, if you have a typical application, it's very easy to build one. You can take a kind of a bottom-up approach, where you say, okay, so I know what the application is supposed to do, so I'm going to design my database, I'm going to design my schema, I put people and their hobbies and so on. And then you use an object relational mapping, which basically transforms the data and the schema into OO, so objects in your favorite programming language. And then you put a web application framework on top of this that takes care of all kinds of common things that you would need in a web application. So say routing, caching, authentication, all these kind of things. And the reason is that basically over the course of web development, people have kind of learned to recognize certain patterns. So for example, this model view controller pattern. And they have recognized that many of these web applications use this pattern. So they say, let's build a framework where the model is provided by the database, you have this OR mapping, and then you basically only have to do the views, and the controller is basically kind of a standard approach. So you have many of these frameworks, and just list a couple here, depending on your favorite programming language, like Rails, Django, Clone, Zend, Struts, Nitro. And they all do this. So they take a database, they transform it into OO code, and then you basically do the application-specific things yourself. But it's a very rapid way of development. Now, let's look at semantic web today. So we have a lot of data. We're getting more and more data. If you pay a little attention the past few days, you have maybe heard about this linking open data, publishing open data initiatives. There's all the time more data becoming available in RDF online. We also have a fair number of RDF stores which are maturing all the time, in which you can store this data. So you can get data, you can store it, you can set it in your RDF store. And then what? Data does not make an application yet. So basically what you need to do currently is you have to do all the rest by hand. And what would be nice, and what I will try to present in this talk, is if we can use a similar architecture. So you want an object relational mapping, except you don't map relational data, but you map semantic web data, and you want to reuse the web application frameworks, because they can do the kind of typical web applications part for you. And the only thing you need to focus on is the semantic web part. So in the remainder, we'll discuss this library called ActiveRDF that does this mapping for you and integrates with Ruby on Rails so you can develop in combination semantic web applications. But first, I will demonstrate you very briefly kind of a movie from an application. I have to say, ActiveRDF is a library. It's kind of middleware, so it's very hard to demonstrate because there's not much to see. So what I will demonstrate is an application that's built on top of it. And this is just an example application, right? It's just an example application a student of mine wrote very quickly. If you don't like the application, you can develop your own application on top of it. So what the application does, it aggregates data from online social communities. It's basically like a RSS aggregator ++. And it uses this shock vocabulary for describing social communities. So forums, blog posts, mailing lists, all kinds of things. People are really starting to publish this in this shock vocabulary, which is an RDF format. And you can pull all this data in. And then you can browse it in an integrated manner, and you can filter. Like in an RSS aggregator you can filter, but in RSS you can filter on a very limited set of properties. And because this is RDF, everybody is able to express their content in a much richer way. So you want to also navigate and aggregate this information in a much richer way. So let's see if I get the demo working. I'm not sure if it displays very well on this screen. So let me just get to the start of it. Yeah. Okay, so I made it screencast because I wasn't sure if the internet was going to work. So what you see, we have, I will just very briefly go through this, okay? It's not too important for the rest of the talk, it's just a demonstration of what you can do with it. So we have aggregated 7 of these so-called forums. They can be real forums, they can be blog posts, they can be mailing lists or whatever. And you see them, and you can basically click on one of them, and you get the recent post in these forums, and you can collapse or open them up, and you can read it. So this is like a news reader, basically. So this is all data exported in RDF from different people. So you can read this, and you see some metadata, and you see the actual post, and you see the replies down there as well. And you can read more of these things. And you can just browse this in a kind of chronological way. And so there is some post there. And what you can see is, because this data is integrated over various of these forums, is you can do kind of cross-browsing. So when you're looking at one forum, you can, for example, like in tagging, right? So you can say, okay, this post was tagged with, say, the web. Let's see all the other posts that were tagged with the web. But you can do this also over temporal data, over user data, over replies, and over all kinds of data. So let's just look here. We're now selecting other posts across the whole aggregation from a certain month. So we're now browsing in all the forums over February 2007. So we can just now look at all the different posts that were made in this month. And let's look at all the topics that were mentioned. So there is all kinds of topics there. And we'll filter down on the web. And now we found, so we started on one forum site, then we go up basically to all the forums, but in a certain month, then we filter down again on a certain topic, and we arrive in 2 posts that were made in this month on this topic. And by some user called Fred. I don't know who Fred is, so we click on Fred, and now we see all the posts that were ever written by Fred. I don't know in which forum, they are aggregated from any place, so he could also have to send a reply to somebody somewhere, he can make his own blog post, I don't know. So you can browse this kind of aggregated picture, and you see the replies that he ever made and so on. So that's the end of the screencast. The thing I just want to mention is this demo involves crawling. You need to get the data, you need to crawl it, you need to integrate it, then you need to have this kind of web interface. You need to allow filtering, you need to generate this, you want to cache it and so on. And this is all written in 350 lines of code, which is, I don't know if you find it much or not so much, but I think it's quite reasonable. So you can very quickly prototype or develop applications in this way. And this uses ActiveRDF obviously and Ruby on Rails. Okay, so now let's look at this mapping. So let's look at this mapping. So intuitively, you would think, you know, we have RDF and we have RDF schema, so we can just map the classes in RDF schema to OO classes. We can just map the resources in RDF to OO objects, and we can just map every triple to kind of attribute values. So if you have this example on this is kind of an RDF syntax with a couple of mistakes, so if you find mistakes, I would buy you a beer. But it basically says there is a person class, then John is a person, and John has a name, John Breslin. So this is a snippet of RDF. And intuitively, you could translate that to say this UML diagram, where you have a person with an attribute name of type string, and John is an object or an instance of that class with a value for that name. So that doesn't really work. It works to a certain extent, but it doesn't really work, and I will show you later why it doesn't work and why you have to be careful to do this. And the reason is, of course, that RDF schema is not the same as OO, so you cannot just translate this like this. But let's, for a second, continue. I will give you the complicated stuff later. So let's look at some examples of what ActiveRDF does. So if you have never seen Ruby syntax, then just bear with me. Okay. So you can do the same in another language. This is just an example in Ruby. It's my favorite language. So we register some shortcut for a namespace. So the whole idea of ActiveRDF and of actually all these OR mappings is that you have proxies in your OO language that represent data in the data model, or in the database, or in the graph. And methods that you call on your proxies are translated into operations on the database or on the RDF graph. So what you have here, this is just a register a namespace so that you have kind of a short way of talking about FOF data. And then you just say, let's create John, which is a FOF person, using this URI. So now we have John. Okay? And now we can query the data. Let's find out. So John.FOF knows will retrieve everybody that John knows. So we're following an outgoing arc. So everybody that John knows, and then we iterate over this. So each is just a standard Ruby iterator. And for each of the friends, we put, which is Ruby for printing stuff. So we put his FOF name. So this in the background will of course generate all kinds of queries to the data store, but you're just retrieving all friends, and for every friend you're printing a name. I will show a couple of more examples later on in the paper. There are also more examples if you're interested. So another thing you can do, instead of a kind of an object level, you can go onto the class level and you can find resources that satisfy certain conditions. You can also, of course, just write normal queries, but if you want, you can also do this. So you have a class FOF person, which represents the RDFS class, and you can say, find me all the persons with the name John, or find me all the persons with the name and age John. Now the interesting thing about this is not the syntax or whatever. The interesting thing about this is that this is not generated in any way. This API does not exist. So this API is virtual. This API is kind of mimicked. Because if you would generate it, you are fixing yourself to a schema at the time of generation. But this is virtual. So I will give you a little bit more details about that in a second. So this is the architecture of how ActiveRDF is built. So if you're an application developer, you're sitting here. And the only thing you care for is the object manager, which is what you just saw. The other stuff is what we need in order to wrap all kinds of data sources that behave quite differently. So So what we have currently in semantic web land is we have a lot of different data sources, RDF triple stores or other kind of data sources, and they all implement different APIs, and they all implement different query languages, and we have now Sparkle, but this is only a read query language, so we cannot actually uniformly access all kinds of triple stores or other kinds of data. So we have adapters which wrap particular data sources. These adapters offer basically kind of a homogeneous API over all kinds of data sources. Then we have a federation manager which can talk to multiple of these data sources at once, so you can do a query over a distributed set of data sources and aggregates the query results. Then we have a query engine which offers a kind of abstract query API, because again, we don't really have right now a standardized query capabilities of all these underlying data stores. So they implement different query languages with different expressiveness. Some do keyword search, some do not, and so on and so on. So we have kind of a abstraction layer on top of that. And then we have the object manager, which is the thing that the application developer would be talking to, which kind of not really generates, but which pretends or mimics these proxy objects that you actually use as data. So I will go to now in a little bit more detail about how this object manager works and how these adapters work. Just check how am I on time. Okay. So this object manager, like I said, represents RDF resources, but also RDFS classes, because they're also resources, through these proxy objects. And what happens internally is we intercept every method call that is done on this proxy object, and then internally it's basically converted into a query or an update on the database, a data source. And the same for these dynamic finders, we also rewrite them in queries. So for example, if you have here print or puts John Fauve name, we intercept this method, we interpret this to be a query over with S, subject is John, and the predicate is an expansion of Fauve name. And then we give you back the result. If you do this, this is kind of adding Jack to the list or to the set of known friends of John. So this will generate an update on the data source. Now that depends, of course, if the data source is actually update capable. So if you only have a Sparkle data source, you cannot do this. But if you have, we have all kinds of adapters for different APIs, and most of them actually allow updates. And similarly, if you do for person find all, you basically this is caught and generated in a select all the subjects with type person. You can, of course, like I said, you can also write your own queries, but this is for more typical access patterns. And so the interesting thing is this is not generated, this is virtually, this is by doing reflection and method interception inside Ruby. And now these adapters, like I said before, they abstract data sources. They can be most typically RDF data sources, but it can of course be any other data source as well, into kind of a homogeneous API. So currently we have implemented adapters for Sparkle endpoint, for Sesame, Jenna, Yars, and Redland. And if you want to have your own triple store editor, just if there is a user, we can write an adapter very quickly. You can also write wrap application data, actually. What we have done is we have wrapped an adapter around emails. Why not? So all the queries that come into this adapter are just rewritten into some native API of this email store, like Outlook, and then the RDF is generated back on the way out again. And you can also wrap arbitrary desktop metadata and so on. So what this gives you is you can reuse the whole ActiveRDF framework, but you're not confined to specific triple store or to specifically RDF data. You can basically use arbitrary data sources. Okay, so let me go a little bit in detail about problems with this intuitive mapping and why it doesn't work. I mean, it works, but you have to be careful about certain things. So the problem is basically that RDF schema is not an OO class definition. And most importantly, in OO languages or in OO type systems, typically, not always, so this is a kind of a broad classification, but typically you have class definitions, and the class membership of objects determines their instance behavior. So it's kind of top-down. If you're a member of a class, you have the certain attributes, you have certain methods, and that's it. Whereas in RDF and RDFS, it's actually bottom-up. So if you have a certain instance behavior, if you are a resource with a certain property, you all of a sudden belong to a class. So from instance behavior, you infer class membership. You don't go top-down. And this has several consequences, and one of the maybe interesting ones, because it immediately shows that there is a disconnect between these two worlds, is if you look at how properties propagate and how in OO instances are inherited. Okay. So I will not go into detail because I see we are running actually very tight on time. But if you look in OO, if you have this simple UML schema, right? So all cars are all vehicles, and all Ferraris are cars. So there is a subclass there. And a car has an attribute engine, then it's inherited downward. So all Ferraris also have this attribute engine. Now if you look at the simple RDF schema, just look not on the right hand side but on the middle hand, a simple RDF schema that somehow models this similarly in RDFS, you could say, like here, a car is a subclass of vehicle, a Ferrari is a subclass of car, and engine has a domain of car. Okay? But what follows now out of RDF schema semantics is that engine has also an RDFS domain of vehicle. So if you make a picture of this, is that actually engine in a way propagates upward. You may think I'm completely crazy, and the reason that I'm not crazy is that this picture basically, you should not make this picture. Because what I'm doing here is I'm making kind of a UML diagram of an RDFS schema, but this is not a UML diagram, and this means completely two different things. So the reason engine is here completely correct. Because what engine means, what it means that engine has a domain car, means everything that has an engine is a car. Right? But everything that is a car is also a vehicle, so you can just say that everything that has an engine is a vehicle. But if you look at this from an OO perspective, you think, why do these attributes propagate upwards? What's going on? And what's going on is that RDF schema is not an OO class definition. Okay, so I will now walk through this very quickly. Just read please in the paper more detailed the exact problems that you run into and how we can basically carefully circumvent them. What you need to do is you basically need to be careful. So there is 6 kind of problems you can identify that follow out of this. Is typically RDFS resources can have multiple types, and typically in OO objects can have only one class, and the one class defines exactly the behavior. And in OO objects cannot have different behavior than their classes prescribe. If you look at the class hierarchy, in RDFS it's no problem to have multiple superclasses. Why? Because basically the superclasses don't mean too much. They only mean that you inherit a type. And it's no problem to have multiple types. But in OO, you typically have single behavior. Why? Because in OO, the inheritance behavior will propagate method and behavior. And this is much more complicated if you have a multiple superclasses to figure out which behavior then to use. So you want to allow the RDFS multiple superclasses, although you're inside an OO system. Third thing, as I said before, in RDFS, the class definition is not exhaustive, right? It does not really constrain the structure of its instances. You can have a class definition, and then you can be a resource, and you can still have any property you want. In OO, it's the other way around, it's top-down. So the objects must follow exactly the definition of the classes. And that's for memory reasons and all kinds of reasons. The solution here is that you should not enforce the class definitions if you want to treat RDFS data. So I'm walking a little bit quickly over this because we are showing time, but you can read this in the paper, and in the paper I also explain why Ruby or dynamically typed scripting languages are very appropriate to deal with RDFS data, and why they help you to basically mitigate these problems or get around these problems. So very quickly, just I want to make clear, what about relational mappings, right? We have this in a relational setting, we have these OR mappings. So why is the problem there, why doesn't the problem there exist? Well, the thing is that relational tables and these mappings are much closer to each other. So if you're traditionally or classically you map tables to classes and tuples in the tables to objects. And then all these mismatches we just mentioned before, they don't occur here. If you look at class memberships, tuples belong already to exactly one table, as in the OO model. If you look at class hierarchy, there is no hierarchy in a relational database. If you look at object conformance, tuples must conform exactly to their table definition. If you look at object attributes, columns are already local, so again you don't have this one. If you look at structural inheritance, it doesn't exist. If you look at flexibility, again, like in an OO system, in a relational database you typically don't evolve the schema in runtime. So the point is that in the semantic web setting or in RDFS setting, you get all kinds of problems that you don't run into in a database because you are in an open space where things are different than in a closed system as in a relational database. Okay, so this will be my last slide. Now, how can we use this to build web applications? It's basically you can use Ruby on Rails, which is an existing web application framework, which uses this model view controller paradigm. And you can stick in ActiveRDF as models. So you can reuse the whole ecosystem and whatever of Rails and just use ActiveRDF to talk to semantic web data instead of a relational database. So you have a semantic web application where ActiveRDF takes somehow the semantic part for, and Ruby on Rails does the web part. So I will skip the performance side later, and you can read it in the paper, and you can download it in this URL if you are interested, or you can see this site for more information as well. Thanks.